unfortunately, I'm down to 10 weeks and a lot of material. So please slow me down anytime you feel like it. So here we're talking about differentiation rules. So this time we're not going to have to use f prime. And this is a comment. Many of you wrote f prime without the limit operator and went ahead to f of x plus h minus f of x divided by h. And of course, the answer was wrong because you're not applying the limit. So if you don't apply the limit, as we discussed, the derivative is a combination of two concepts, the difference quotient and the limit. If you do not put these two together, you cannot find that. But this time, we're not going to use the definition. We will, because I want to show something every now and then, but this time we're going to go directly to differentiation rules. So here is one, which is the power rule, x to power n. Yes, we can do this. We can use a definition, the formal definition of the derivative, but now we can skip that and we go directly to formulas. N, x to n minus 1, and it should be multiplied by x prime. Remember, x prime is nothing else but the slope of x. Can anyone tell us what is the slope of x, or the derivative of x, in other words?
Is it 1 over 2x?
Very good. It's 1. Y equals x. The slope is 1. So that's why the derivative of x is 1. So therefore, there is no need for this. I'm making a point for something else that follows. So if I have, let's say, x to the 7th power, I have 7x to the 6th. I should write times x prime, but I will not. Why? Because x prime is 1. Thank you very much. That's why. Good. I would like us to also talk about something like a constant times the function prime. So that is the constant times the function prime. And this is a factor. As you see, it's multiplied. Now, if I have a constant, any constant prime, what is the rate of change of 5? I have $5 in my pocket. What is the rate of change of 5? How fast does 5 change? So y equals 5 is a horizontal line. What is the slope of a horizontal line? Anyone? So are we getting stuck on the slope of a horizontal line? Ethan, RJ, Sean, Janelle, Christine, Isaac, Elena. Can anyone give us the slope of a horizontal line?
Zero.
Thank you very much. So the derivative of a constant is always 0. So now if we want to differentiate a polynomial, can anyone give us a polynomial? Anyone? A polynomial, any type of polynomial, any degree. Anyone? Okay, so let's say 3x cubed plus 2x minus 1. And let's say we want to determine the function that gives the slope of the tangent line or the average rate of the instantaneous rate of change of this function at any point, because this function is differentiable everywhere. So we bring down 3, we multiply by 3, we get 9. We subtract 1 from the power, and 3 minus 1 is 2. And we differentiate 2 times x, and you get 2. So this is the derivative function of this function. Now, one other function that I would like to talk about is e to the x. So if we have f of x equals e to the x, the derivative is itself. This is a very, very nice situation, very nice function. So e to the x, it's the derivative of the function e to the x is e to the x. I should write here multiplied by natural log e. I'll explain why later, why I will get this, where I need to talk about it. But what do we know about natural log e? Can anyone tell us how much is natural log e?
It's 1.
Indeed. So that's why we will not write it. What is the point here? What am I trying to say? Well, I'm trying to prepare you for something else, which is f of x equals a to the x, where a does not equal e. So see, we have exponential functions that have base e, natural exponential function. And we have exponential functions that have any other base, not e. Well, that's why this comes into play. I wanted you to have it here so you know there is no need because natural log e is 1. But when we differentiate this function, f prime, I didn't want to put it to the side. So when we differentiate a to the x, we will write a to the x, but this is no longer 1, so we have to multiply by natural log a. So see the difference. This is still the same thing, but it happens that natural log e is 1, that's why there is no need.
I have a question.
Anytime, yes.
So when you're saying that that a is not equal to e, are you saying exactly that, like a cannot equal e or a cannot equal 1?
Very good question. Exponential function has 2 possibilities. For a, the base, to be in the interval 0, 1, or the base to be in the interval 1 to infinity. A can never be 1. It will not be an exponential function. A cannot be 0. It will not be an exponential function. It will not be a negative number. By definition, the exponential function can have anything between 0 and 1, not 0, not 1, or a number between 1 and infinity, but not 1. So there is no discussion for this to be ever 1, or 0, or negative. I'm saying a can be any number between 0 and 1, and 1 to infinity, but not e, because I already have a formula for e. I don't need the formula for e. I need the formula for anything that is not e. Is that okay?
Yes, thank you.
Perfect.
Sorry, can I see that page from before?
Yes, anything. Oh, I'm sorry.
Okay, I just want to leave some space for it. Okay, thank you.
Thank you. Good, so let's select a few questions from, okay, let me share my screen. Here it is. Okay, so anything from 3 to 34, we're asked to differentiate the function. We can choose anything you want. So let me go back slowly, and you choose.
Can you do number 29?
29 it is, very good. Here's 29. And f of z. I'm going to reuse x because I don't want to confuse you. So this is a plus bx plus c x squared divided by x squared. Perfect pick. So if you remember, we always talked about two keywords, factor and simplify. They should always be in the back of your mind. So there is no need to factor. I can factor, but I can simplify, and I will do that. I will prepare the function to make it easier to differentiate. So a over x squared is a times x to negative 2. bx over x is b times x to negative 1. And cx squared over x squared is c. So what I just did was I wrote that a plus b plus c divided by d is a over d plus b over d plus c over d. This is one fraction, this is the second one, and this is the third one. So a divided by x squared, we know how to write it. bx divided by x squared, we know how to write it because I simplify an x, but I still have an x in the denominator. And here these two go away and I just have c. Any questions?
I have a question. Would
Sure.
you be able to do that part again slowly, please?
Yes, a divided by x squared can be written as a times x to negative 2. bx over x squared, you simplify an x, you have b over x, so this is b times x to negative 1. And when you simplify here, you just get c.
Thank you.
Thank you. So we prepare the function, now it's ready. We bring down the power, negative 2a times x to negative 2 minus 1, plus bring down the power, negative b times x to negative 1 minus 1. And when I differentiate a constant, what do I get? Christine, how much is a constant prime?
I don't know.
Anyone else?
0.
0, very good. So you can leave it as is, or you can write negative 2a over x cubed and minus b over x squared. So this is the derivative of the function that you picked. It's the derivative function that gives us the instantaneous rate of change of function f of x at any point where the function is differentiable. And we know it's not differentiable at 0 because it's not defined at 0. Is this okay? Good, so let's share. Good, anything else you would like to choose from here? And then I would like to talk about this notation. We can move on and determine and look at any of the problems 37 through 40, in which we are asked to find the equation of the tangent line to the curve at the given point. We can move even forward for determining the equation of the tangent line and the normal line. Anyone would like to pick, or I will?
Can you do number 40?
40, very good. Let's continue with number 40. Very good. You said 40?
Yeah, 40.
Very good. So let's look at 40. In 40, we have y equals the fourth root of x minus x at 1, 0. And here they just want the equation of the tangent line. Perfect. Very good pick. Of course, I will prepare my function. And this will be x to 1 over 4 minus x. I differentiate. I have two options of writing the derivative. I can write f prime of x, which is the same with y prime. Same thing. And we have a similar notation, alternative to this, which is called the Leibniz notation, the derivative of y with respect to x, dy over dx. So all these mean the same thing, f prime, y prime, dy over dx. This, when I want to evaluate it at x equals 1, however, I will have to write a vertical bar, and at the bottom here, x equals 1, which means I will find this function and then plug in 1. This is easier as a notation because I have f prime of 1. Done. Good, so let's find that first. I'm going to use this notation just for us to get used to it. We're going to use it a lot in certain situations, you'll see. I bring down the power, and I subtract 1 from the power. A quarter minus 1 is negative 3/4. And the derivative of negative x. Can anyone tell us what is the derivative of negative x?
-1.
Very good, awesome. At this point, I know that I need to determine the equation of the tangent line. Y minus y1 equals the slope times x minus x1, where x1 is 1, y1 is 0, and this is what I'm after. But this is basically f prime of 1. And that's what I have when x is 1. And let's see what I get. How much is 1 raised to negative 3/4? Can anyone help? 1 raised to negative 3/4.
It's 1.
Thank you very much. And 1/4 minus 1, negative 3/4 again. So this is negative 3/4. So y minus 0 is just y. Negative 3/4 is outside, and x minus 1. And we need to distribute. So y equals negative 3/4 x and plus 3/4. We have to present the equations as y equals mx plus b. The slope is negative 3/4. And the y-intercept 0, 3/4. Perfect pick. Now let me do this. I just want to continue. Let's suppose we are also asked to determine, so this is the equation of the tangent line. Tangent line at 1, 0. But now, let's suppose this is the graph, and let's suppose this is the point 1, 0. And this is the equation. It's not going to be that, just because the slope is negative, so I will have something like this, not like this. But I'm just explaining the idea. So this is the tangent at the point. How will the normal line look like? The normal line is a line that is perpendicular. So this is normal. So these 4 angles are 90-degree angles. So the 2 lines are perpendicular. They form 4 90-degree angles. So we determined the equation of the tangent. Let's suppose now we're adding a part to this question. Let's suppose we're asked to determine the normal line. How do I determine the normal line?